Hello everyone, I hope you all are well and making progress in life. Here is Priyanshu and welcome to the Infinity Mind. So today we'll be solving the problem Palindrome Linked List. So we are just given head of a linked list and we have to determine that whether it's a palindrome or not. We just have to return true or false. If this linked list is a palindrome, we have to return true, otherwise false. So in the example one we can see that 1 2 2 1. Yes, we all know what is a palindrome. That from if we read it from starting and the number is coming 1 to 2 1, and if we read it from backwards the number is again coming 1 to 2 1. All right. Then if both numbers while reading from backward or forward, if they come same, we can say that it's a palindrome. So yes, first is a palindrome, but in second, in the it's not a palindrome because while reading forward from left to right, it's coming 1 2, and from right to left, it's coming 2 1. So it's not a palindrome. So here we will return false. So now how we can solve this? So now the brute force approach. The brute force approach which can come into my mind just doing whatever the question is saying. We have to check palindrome. So what we can do that we can use a stack. All right. So suppose we have this example, we can use a stack and store all the elements into the stack. First one is there, I will store one. Next two is there, next two is there, next one is there. This is a stack. All right. Now this is the first iteration. We are storing in the stack. Now in the next iteration, when we will pop it again our pointer will be at the starting and we will compare the elements in the stack. We will pop first element and we will compare this from this our current node. So if this not current node, value of the current node. So if 1 is 1 equal, 1 and 1 are equal, yes. Next it will be here. Now we will pop 2. 2 and 2 are equal. Next 2 and 2 are equal. Next 1 and 1 are equal. Similarly, with the principles of stack, we can just check by using stack that it's whether a linked list is a palindrome or not. But we all know this will take big O of n extra space for storing all the linked list elements, and 2 times iteration we are doing. So first iteration for storing into the stack and next iteration for comparing. So this will take time complexity of big O of 2n. Now how we can reduce this space complexity of big O of n? If we do not want to use this space, so how we can complete this? So, and here in follow up it is also written that could you do it in big O of n time and big O of 1 space. So let's try how we can do this. So I have taken an example of a linked list. So what we can do, we have to check palindrome. All right. So we all know that if it's a palindrome, then first three, this is coming 1 2 3, and if we compare the last three, if the size of this linked list is even, let's say I am here taking case of even size linked list, we can what we can do, we can find mid. So here we can, there are two middles, there are two middles here, so we'll find the first middle. So we have find the first mid, that is 3, and from this mid we will, what we will do, our next mid, that is next of the mid will be our second linked list. All right, the next of the mid will be our second part of the linked list, second half of the linked list, I would say. So now we have to just compare this and reverse of this. So what is the reverse of this? This will be 1 2 3 if we reverse it. Now we can, if anyhow we reverse the second half, and now we use two pointers we put pointers here and one pointer here. Now we can move pointers and check if all the values are same. We can say yes, it's a palindrome. Now how can we do this? So we what we can do, we can first of all find middle. All right, we can find middle. So we know how to find middle of the linked list. We know how to find the middle, so we can easily find it. uh, uh, if you don't know, you can go and watch my lecture on how to find the middle of the linked list. It's very easy. We can use just two pointers, slow and fast, to find the middle. All right, so what happens, first slow and fast is here at the starting. Now we will keep moving slow and fast pointer. So slow will be here, fast will be here. Next slow will be here and fast will be here. Now we have to stop here because we have to find the first mid here. All right, we have to find the first mid here. So if the we have to stop, when we have to stop, when fast of next is null. So we have to stop now because we have found the first mid. And all right, so we have found the mid. Now what we can do, we can just call, we can just store this next node as let's say next node. All right, so from here to the entire second half linked list, we can go for reversing it. So if we go and reverse this, so this will be looking like, this linked list will be looking like 1 2 3. If I delete the above things, so I should delete everything. So we have found middle. We will write a separate function for finding the middle. So here I am finding first mid, and I will tell you why I am finding first mid. But uh, after finding the first mid, next node will be the starting of the second half of the linked list. And now I will call reverse function, and in the reverse function I will send this next node, and this will reverse my linked list. So my linked list will be looking like something after reversing this. This will be like this. This second half of the linked list will be reversed, and this 3 was pointing to what? This 3. So my linked list will be looking like this. Now my next node was on this, my mid was here. All right, after reversing it, my new head will be returned using the reverse function. If you know how to write the reverse function code for reversing the linked list, if you don't know, you can go and watch my lecture or any other lecture on YouTube. You can just go and check it. There are two methods, first is iterative and second is recursive. Both are same, just a way of writing the code. So after reversing this will come, and now we can use two pointer techniques. We can use two pointers, pointer 1 here and pointer 2 here. All right, and what will be pointer 2? This will be the new head, because the reverse function returns the new head. All right, so new head will be this. So new head will be this, and now this will be my pointer 2, and pointer will be my the original head, the original input head. So now what can I do, that I can keep moving pointer 1 and pointer 2 and checking that if their values are equal or not. So here in this case, p1 p2 both are equal. Okay, now move ahead. Now p1 p2 values 2 and 2, they both are equal. That's good, and I will move ahead. Now again p1 p2 are moved, and again values are same. Now both will be null, and I will say that I'm out of bound and it's complete now, and I will return true. And in the else case, if any values are not same, I will return false immediately. So this was the whole logic, that first of all I will find mid, and if this is even size linked list, I will find the first mid. And the reason for finding the first mid was just to store the next of the node and go and reverse it. And I can now easily reverse it. And and you know why I in the normal finding the middle, the LeetCode, another LeetCode question, it was said that to find the second middle if the size of the linked list is even, but I am finding here middle one, the first middle, because uh, suppose if we are sitting in an if we are sitting in an interview, and it's a good practice not to modify the original input, because if we are working in a real company, real workspace, so it's not good to modify the original data. So either we can either we should ask the interviewer to, if we can modify the original linked list or not, or we should use a copy. And so that's why I use the first middle, because after reversing, my linked list will look like this. And now before returning, what I can do, I can just again I can again call reverse function to reverse uh, reverse my linked list. So I will send their new head, and I will ask to again reverse this. So my after reversing this, it will be looking like this again. So everything will be now okay. My 3 will be pointing to 3. All right. So this was the case. And in the odd case, when the size of the linked list is odd, so again we will do the same. All right, we will again call the mid. Here mid is normally the normal mid, we will call. And our next will be this, we will just ask to reverse. So this will be reversed, and this will reverse the linked list. And now our linked list will look like 1 2 3, and this will be pointing to this. Now we can use two pointers again. So if I tell you here how I have found the mid, and but before telling how we have found mid, I should complete this explanation, that I can now move pointer 1 and pointer 2 both. So my pointer 2 was at the new head there. So now this one and this one are equal. So I will move both pointers. Now pointer 1 and now both are equal, I will move both pointers. So I can see that my pointer 2 actually has gone out of bound. So I will stop. In the first case also, I mistakenly said that my pointer 1 also gone out of bound, but after iterating from 3, the pointer 1 has gone to here, but pointer 2 has gone out of bounds. So here in this case, when my pointer 2 will be out of bound, when it will be null pointer, then I will say just stop and return true. If in any of the cases P1 and P2 are not same, because if any of the cases P1 P2 are not same, we will say that it's not a palindrome. All right. So just this was the logic to find the middle, and just reverse the next half and use two pointers to compare just this thing. So this way we are not using any extra space. And first we are I will tell you time and space complexity also. Middle, finding middle, this will take big O of n by 2, and reversing this will also take big O of n by 2. All right. So, and we are iterating two pointers also. So at max the two pointers they will travel big O of n by 2. All right. Is there any other thing? So we will check in the code that we have reduced our space complexity to big O of 1, and time complexity will be approximately big O of 2n. All right. So if I now implement this, so first of all what I was doing, I was finding the middle. First I was finding middle. All right, so now I will first find the middle of the linked list. But before finding middle, I will handle the edge case that suppose if head was null, if head was null, or the head next was null, it means that suppose head is null or either there is only one node. So what we will say in that case, we will say that yes, it's a palindrome because a single node is a palindrome, or there is no uh, if head is null then it's a also a palindrome. Next I will go and find the middle. I will just call my middle function to find the middle. So middle, I will send the parameters. I will just send what I have to find. All right, so I will call this middle function. After finding middle, my next node, I will just say my next node will be next of mid. All right, now my next node is ready. Now I will call the reverse function to reverse my second half of the linked list. So this will return a new head. So I will call my reverse function reverse, and I will send there the next node. And then after it is reversed, I will use two pointers. So my first pointer will be pointing at the original head, and the next pointer will be pointing at the new head. All right, and now pointer 2 is ahead of pointer 1. So if pointer 2 will exhaust while pointer 2 is alive, so I will keep traveling, and I will just compare the values. If value of p1 is equal to value of p2, I will say it's all right, and now just move ahead. So p1 will be next of p1 and p2 will be next of p2 if both values are equal. If in any case, both values are not equal, if both the values are not equal, so what I will do, I have to return false. But if we are sitting in an interview, we should always correct the original linked list. But it's not asked here, but I'm doing this. First of all, I will reverse it, new head. Now this will help me reversing again the linked list, so that my original linked list did not get disturbed. Now then I will return false. In the if both values are equal, then I will say just move ahead, else reverse and just return false. Now after coming out of while loop, suppose everywhere we saw that values are equal, and they just p2 has came now out of bound. Now what I have to do, I can just return true, and yes, before returning true I will just fix the original linked list. Alright, not necessary, but yes, good practice for the interviews. And now I think I am done. I have to just write the middle function and the reverse function. So middle was what parameter it was taking? It was taking just head. So how can we find middle using slow and fast pointers? So slow will be initially add head. We all know. If you don't know, you can just go and find on YouTube. It's very easy. It's very easy. All right. So now slow and fast are initially here. Now what I said, in the even case, if fast has, if slow was here, fast was here, then slow was here, fast was here, then slow came here, fast came here. Now we are at the mid. When fast next to next is a null pointer, right? When we find next of fast is not a null pointer, and in the odd case, slow and fast, next slow will be here, fast will be here, next slow will be here, fast will be here. Now we are at the mid, and when we are at the last node, we will also say that we have find the mid, that is slow. So if fast of next is alive and this is alive, we can just say that move ahead, next of slow and fast will be next of fast. All right, and after this will break, I will just return slow. This will be my mid. All right, and now I'm going to write the reverse function fastly. So reverse function was also taking a head, and there we used a pointer current pointer was my head, and my previous pointer was initially null pointer. Let's say my next node, no problem, I'm saying it's null pointer now. And now while my current is alive, I will go and say my currents next is my previous, and now, but yes, what's my next node? My next node is next of current, and my previous is now updated to current, and my current is now updated to my next node. All right, now at last I have to return the new head, that will be my previous. So I think I am done now. I should run the sample test cases and check if we are able to pass the sample test cases, and yes, and if I submit this and check if we are able to pass all the test cases or not. So yes, we have solved this problem now successfully. And talking about the time and space complexity, so in this function is palindrome, we can see that we are finding middle, and we are finding middle. This is taking just uh, in finding middle only, this is taking big O of n by 2 time complexity, we all know. All right, next finding the reverse, this is also taking big O of n by 2 because we are reversing half of the linked list. All right, so n by 2, this is big O of n. Now we are in a while loop, we are using two pointers. All right, we are using two pointer techniques. So our pointer is moving, this pointer is taking big O of n by 2 time complexity because they are traversing half of the linked list. So big O of n by 2 again, so this comes up to around 3n by 2. Now at last we are also reversing it, and we are just reversing one time. So this is also taking big O of n by 2. So overall time complexity comes to be big O of 2n, but I would say with the rules of time complexity, I would say that this is big O of n. And space complexity, we all know we are not using any extra space, so space complexity is big O of 1. So this was all about this problem. I hope you understood. Thanks for watching. Till then, keep learning and keep upgrading yourself. See you in the next video.